this presentation was all built in HTML, so you can just open these up in your browser. All right, so we'll just start with this one, Python and FLAC2D. And forgive me if we run into all of a sudden, oh, FLAC3D, I missed something in the presentation that Jason made, and I'll correct it. All right. Python is a general purpose programming language, extensive scientific programming functionality. It is integrated into PFC2D and, FLAC2D and PFC and FLAC3D and a little bit in 3DEC. Yes, free, fast, and easy to use. It's debatable, but yeah. This is a very general speed comparison. So if you had a fish function, maybe you were looping through a number of zones, and the base would be the fish function. So that's one. And if you did the same procedure in Python, it'd be about 2.5 times. For just looping through zones or stresses. Stress counting would be about 1.8, and so forth. And then NumPy, which is a special array manipulation package, you can get some very, very high speed up numbers. More complicated to use, but very, very fast. Okay, so a very important concept that we'll always go back to is the idea of the model state. And simply put, this all has to do with issuing the model new command. So you definitely ran into that now. You know that when you issue model new, everything is cleared. All your fish variables, all your functions, the entire state, everything is reduced back to 0. That is not the case in Python. If you issue this command, Python, and we'll talk more about IT and all this import crap later. If you just issue this command, Python reset state false, that means on a model new, you are not going to clear the Python data. So if you create a variable like George equals 1 in Python and issue model new with this command set, that will not be erased. And the reason we did that was so people can run parameter studies where you can say, I have a list of Young's moduli, and I want to run a UCS test with each one of these different moduli. And I just want to say, run it, do this moduli, moduli every time, and I want to see the results. And I'm going to issue a model new each time I run my model. If you did that in fish, all your state information would be cleared. But with Python, you can do those parametric studies, and I'll show you an example of that, and not worrying about all your data being lost each time. Okay, FLAC2D applications. So here's an example. I'll just call this an example. This is a for loop in Python. It's iterating over grid points right now, a list of grid points, which you just talked about, and it's just doing some stuff. It's fast, Python fast, faster than loops and fish. And then you can even go faster to NumPy versions, where now we're looking at NP is basically stands for NumPy, and it uses arrays to do all this looping. Well, it doesn't do any looping. It just takes chunks of arrays, operates on them. And yeah, that's basically the idea of NumPy. It's definitely more of an advanced Python idea. So if you really want to get more into NumPy arrays, we can talk about it later, but just know for now that they're basically the fastest way of dealing with lots of things. Okay, and then with cycling callback and save restored data via extra variables, we won't go into that quite yet. But here is an interesting example, which a lot of people seem to like, is interpolating pore pressure data from like a text file. So you have some data that looks like this, XY pore pressure. So the first value is X coordinate, Y coordinate pore pressure. This happens a lot. In fact, I think this question came up during the fluid flow session. And Dave Russell says we're gonna have basically command that says interpolate all this pore pressure data using all sorts of interpolation schemes of your choosing. You can currently do that in Python quite easily with something like this, where you just import your data as a text file, create arrays of position and pore pressure, and then you create a new array called grid point data pore pressure using this grid data. Grid data is coming from this line here. So we'll talk about the syntax later, but it's saying from the SciPy module that I told you about, there is a submodule called interpolate. And inside there is another submodule called grid data. And it does exactly that. It takes a bunch of data, point cloud data, in our case, pore pressures, and then it will interpolate to your grid. In this case, it would be a grid point in our FLAC2D model or FLAC3D model. And it just sets the pore pressures. Like I said, we're not going into detail here. I just want you to know this is how you do it in Python. You could do it in Fish. You'd have to code out some kind of fancy interpolation scheme, which people have done. But the nice thing about Python is someone has already done that with this in the SciPy package. Okay. So that's just a little bit of teaser saying like, oh, these are the cool things you can do. Doing it in practice obviously is a little different. But I want you to know what is possible in Python in FLAC2D.